What's up, everyone? Taco Pizza Papa here, continuing on in our text-based adventure series, Text-Based Tuesday. Last time we did a tech design for a simple adventure game engine. This is really shaping up to be a choose-your-own-adventure game engine. I don't know if you ever read any of those books, but the idea behind some of those books was you open to a page and you read the page and maybe it describes a room that you're in or something. You get 2 or 3 options to pick from. What do you want to do in this room? And it says, option 1, you open the drawer, turn to page 17, leave into the next room, turn to page 24, so on and so forth. And so you've got this discrete set of options in every single state that just transitions you from state to state. It's quite simple and straightforward, but it can be a real powerful storytelling mechanism. So last time we did a tech design of this. This time we're actually going to build out the engine itself. And we're doing this in Node as a module. So, which reminds me, I need to actually make this a module. We're going to use Mocha for our automated testing. And because we're not building the client here, we're just building the engine, the automated test is really going to be the client. In a future episode, we'll actually build out a simple React client to be the front end of this thing. Let's take a look. Where do we want to start? So the game's going to have a registry of states. Registry has the ability to return instantiated states and transitions. Given IDs, transitions execute method returns a string. State transition method returns instantiated transitions. So the state needs access to the transition registry. So I think where we want to start is actually building out a lot of the transition mechanisms. I am going to start by writing a few test cases because it really forces you to think through how your code is going to be used and how your APIs are going to be exercised before you just go off and start coding classes and functions and things of that nature. And so we haven't created transition yet. So let's actually go ahead and create an empty transition class. And then this is going to have a execute method. And our execute method, if we remember, execute takes nothing. And it is going to return a state. So we know here for transition our constructor, we're going to take a description and we're going to take a next state. And all I want to do with these is set them to ourselves. Oh, heck, we might as well just implement this while we're in here. Yeah, screw writing the test for this first. That's it. That's simple transition. That's all it does. So let's go ahead and exercise this now. So to actually get some test coverage, we've got 2 methods here. We got get description and we have execute. So there's not going to be a lot of meat on the bone for these tests. I'm just going to make one simple transition. All right, now we should be able to exercise this entire thing. And there we have it. We can see our test passed. We can sort of prove to ourselves that they would fail. So here we can see this test failed, this one passed. Test working. Simple transition, done, in the books. We're going to jump to the transition registry. So if you remember our design, we had the various types of transitions. So we also had these notions of factories. So we're going to create a simple transition factory. We're going to take a JSON object in, and we are going to new simple transition. And we are going to assume that we have an o.description and an o.nextState. All right, so now that we have a factory, let's go ahead and create our registry. Now remember, the point of the registry was that it was going to be able to take typed JSON objects and turn them into transitions of the appropriate type. So essentially, we need to maintain a mapping between type identifiers, the strings, and transition factories. So we're going to hand that to the constructor of this thing. So, all right, so this is going to be our transition definitions. Now this is going to be an array based on this schema that we had originally identified. And while it wouldn't be overwhelmingly detrimental to performance, given the size that these games are going to be, to have to iterate through this array every single time, we're gonna transform it into a map. So we're gonna reduce this into a map, and what we want is for each transition, we're gonna say that our map, we're just going to put the current transition into a key of its ID, return the accumulator. All right, so now this should be a map keyed by the transition ID of all of our transition definitions. And then we're also going to maintain a cache of instantiated transitions. So now what we can do is we can say, okay, if I'm going to get a transition by ID, I can say, so if something's in the transition cache, we're just going to return it. If there isn't something in the transition cache for the ID, then we need to create it. To create it, we want to find if we have a factory of an appropriate type. If we do, we're going to use that factory to create the transition, and then we'll cache it and return it. Do we have a transition definition for this ID? Does it have a type attribute? Because if we don't have a type attribute, we can't look up how to make the thing. If we do have a type attribute, do we have something in our factory map for that type? If we do, we're going to get from this factory map the function. The factory is just going to be a function. This is going to be a map of string to factory functions for the type, and then we're going to pass it the transition definition, and we're going to set all that in the transition cache, and then we're going to return this transition cache. If this condition is not true, then we're going to throw an error. All right, so transition registry definitely needs a little bit of testing here. All right, sip of coffee time. Back into it. We want to create a transition registry object that's going to have some fake definitions. It's going to basically have sort of mock data for the test cases that we need. So it's important to note that we don't, when we're exercising this, we're not actually going to pass it, here's the simple transition factory, here's the random transition factory. We're not going to pass it the real things. We could, but then we're not unit testing per se. We're integration testing effectively. And the point of passing in these maps and things like this to the constructor, instead of hard coding in here, here's the factory to use for the type simple, here's the factory to use for the type random. This lets us, one, use this in a broader array of use cases, but two, it lets us actually exercise it in this way. So when we say get transition, and we pass it something with a type of A, we're going to get back the letter A. That's going to be our transition. So we got an A and a B. These two we're going to be able to be successful with. This one, the moment we request T3, we're going to expect to get an error. And then for good measure, we'll do an ID T4. And this one just won't have a type. This is going to be our happy path test case. This is going to be one of our error state test cases. All right. So this is really just testing that we're getting the transition, that it is doing the transformation, that it's doing it in a type-wise way for these things with different types. Really what we care about is that this errors. Okay, so there we go. So all of our tests are passing now. So that is our transition registry. So now we can move on to states, because states and the whole state registry mechanism instantiate the transitions. This thing is really logicless. This is just going to be a mess of getters. Game state, done. So again, this is going to use the same sort of reduction function to take a list of state definitions, just invert them into a map that's keyed by the state identifier. And then we're going to keep, again, a cache. All right, so our transitions, in our state definition, you remember we have a list of, an ordered list of transition IDs. And so this constructor, so we need to actually take that list and turn it into instantiated transitions, which means this constructor needs the transition registry. So we're just going to hold on to that. And then down here, we'll just do bada bing, bada boom. So given a transition registry, we're going to take our current transition identifier, we're going to map it down, and we're going to end up, after this map is done, we're going to have an ordered list of instantiated transitions instead of transition identifiers. So there's our registry. So let's test that one too, because this one has a little bit of logic in it. All right, so we have to think through what we need to test here. We want to make sure that we're able to get defined states given an ID. We want to make sure that we are getting instantiated transitions given a transition registry. And we want to make sure that if we are given a state ID that hasn't been defined, that we are getting an error. So we really just have two test cases. We have a happy path test case and a error state test case. So again, here we are passing the transition registry as a construction time parameter to the game state registry. And if you've ever, in the design pattern literature, if you've ever run across the term dependency injection or inversion of control, that's effectively what we're, that's what we're doing here exactly, is we are injecting the transition registry as the dependency of the game state registry. And we did the same thing on the transition registry by injecting the factories. And the first time I ran across the terms dependency injection, it was always in the context of some dependency injection framework, and it really complicated the matter for me. And it wasn't until a little bit later that I realized that what we were talking about was passing the needs of one object to that object instead of having the object construct its own needs, which really frees you up to use the object in a lot of different ways, but it also frees you up to be able to exercise it in a testing scenario in a very isolated way. So this is just a really good pattern to follow and pretty thoroughly throughout your code to really decouple your dependencies from each other. So let's try to exercise this thing. Did we actually get it in one? I always have to check these every time these tests pass. Okay. Got it in one. All we have left is the game, and the game has two methods. GetState, which returns a state object of whatever the current state of the game is, and we have apply, which takes a transition and changes the current state based on the transition's execute method, and then just returns the new state. Initial state, and we need our state registry, right? Because this thing is going to have to create states. So get state. All this is going to do, we want, we don't want to call this initial state. We want to call this current state. We're setting it equal to initial state. So this is going to say return this.stateRegistry.get state, this.current state. So here, this.current state is going to become equal to transition.execute. That's it. Simple, huh? That's a game engine. So let's actually test this, and this is going to be the test of the engine itself. This one I am going to produce as an integration test because this one I'm going to actually exercise the entire engine. Let's pull in all of our mess. Let's see, what do we want our game to be? We'll have a game that just has a couple different states. So, we'll have a starting state, and from that starting state, we'll say there's 2 paths that you can take. And then in one of the paths, you get to sort of a bad ending state, and then the other path, you get to a happy ending state. So we got to instantiate our various objects. So our typed factory map is going to be mapping the word simple to simple transition factory. So this is going to take game definition states, and it is going to take our transition registry. Then we have game. Before we go any further, let's go ahead and create our game. Let's build out the states first. I think that's going to be easier. All right, so now we're going to define our transitions. So we need these IDs to match. So that's it. That's our 2 transitions. We've got an opening state. We've got these additional other states. So let's go. So let's run this whole thing. Now, just to double check, we're going to put an error in here to make sure that it is actually erroring. So get it back to the happy state. So there we go. So that's our game engine. So we're able to create a game definition that has states and transitions, and we're able to flow between the states by applying those transitions. And so you build this out, we'll add the random transition in, and we'll add a couple more things, and this will give us, a nice little engine to build a client on top of to be able to build little simple choose your own adventure games. So as I mentioned, this source for this is all going up into GitHub. I'll get a README out there that's going to show some usage of it. And the next time we're coding, we will put together a little React client to actually be a front end to this thing. And then, maybe I'll put a little game together and have my daughter play it, see what she thinks of it. So, hey, thanks for watching. If you like this kind of content, if you want to see more sort of Let's Code type videos, leave a like, leave a comment. If you've got suggestions for how to make the engine better, other things that you might want to see built, leave that in the comments as well. And of course, until next time, don't forget to eat your vegetables.